तुम लोग कैमरा बंद कर दो अपना और मनीष तेजेंद्र कैमरा बंद कर दो अपना। अभी हम लोग गैस मीटर चालू करने जा रहे हैं। किसी को डाउट होगा तो फिर एंड में मैं पूछूंगा, ठीक है? तो सबसे पहले हम देखने जा रहे हैं, फर्स्ट वी आर गोइंग टू सी गैस मीटर ऑक्सीजन ऑक्सीजन गैस मीटर. So you can see this is a span gases. You can see methane 10%, C2H2 hydrocarbon is 10% concentration and balance is nitrogen. Isobutane also for hydrocarbon testing. So gas meter and their testing accessories. It's called the span gas calibration. So you have isobutane 0.9%, that is 50% LEL is there. So this is LEL is for checking explosive meter, and this one is for checking hydrocarbon. Here this is for checking multi-gas detector. So in multi-gas detector we can check 4 gases: carbon monoxide, H2S, methane and oxygen. So carbon monoxide ppm is written here, hydrogen sulfide, methane 2.5% by volume, and oxygen 12%. So when we connect this gas to the meter, they should show this reading. That means the material is working correct, and that is calibration. If they are not same, then we will do adjustment. That is again got part of calibration. Like you are doing in a weighing scale, you adjust the zero and the weight. These are the instruments we are going to see. First you have multi-gas detector. So it's all Rikin Keiki. So as we told, multi-gas detector is measuring 4 gases: carbon monoxide, oxygen, H2S and hydrocarbon. Percentage by volume. So you first start the power. See, hydrocarbon, oxygen, H2S. First it will do preparation to see if the battery is working. Filter is okay, sensors are okay, all the checks will be done automatically. Sensor is okay. Then you have last check date and next due date to be checked. From the shore calibration yearly. As per company, we have 2 shifts on-board calibration in monthly or 6 months. Then you have zero test. So first it takes some time to warm up, and after warm up it will start. First after warm up, like a radar, it goes to standby, and then it starts checking to check the gases. So hydrocarbon is zero, oxygen is 21, and H2S is zero. Then you have the zero calibration. Check from fresh air. And power button also is used for enter button also. So zero setting is on now. So this zero means this is the value in air. Now if you want to span or change the reading, you press both pump and zero together to span gas hydrocarbon. So now we can put the span gas. This is the calibration procedure. So now it's taking the gas. Press the pump. So that pump will work, and it will take the gas inside. By pressing the pump, taking the gas inside. Now we are changing the concentration of the gas, whatever is mentioned in the calibration passing multi gases, various gases, and out of that H2S is measuring 25 ppm. It's correct, so no need to correct it or calibrate it. Then you have one more leaking key instrument. Start and check the battery delay. Again, this is a multi-gas detector. It's checking hydrocarbon, oxygen, H2S, and hydrocarbon. So these are upper and lower limits. You will get alarm in lower limit and alarms in upper limit. So all the alarms are showing here. Carbon monoxide 25 ppm. So this is a present reading now. LEL is 0, oxygen is 20.9, H2S is 0, and carbon monoxide is 0. Now we do the air calibration. Air calibration will take the air that means and we see. So again from the air you can see hydrocarbon is 0, oxygen is 21, and other gases. Now we do the span by pressing the reset and display to the air calibration. Air calibration, normal, pump test. check. So auto calibration means if the gases are not having this reading, it will put that reading automatically. It will calibrate automatically. normal calibration mode where you can change the readings. You can adjust the reading in this.
Hi, I'm going to walk you through with this
Here
H2S.
to teach you some of the basic operation of our portable.
Now we'll see some hazardous gas detection. So gas testing is carried out when there are works, you don't need to do enclosed space entry, and there can be some sparks inside or something, so you don't want flammable gas or something. Then multi-gas detector has 4-5 sensors. Oxygen sensor has one sensor, which is paramagnetic sensors. Single gas monitors and multi-gas monitors. Then you have explosive meters and tank scope, which you will see. So first we have to carry out the pump test. Pump test is your circuit, is everything is working fine, internal circuit. Then we do air calibration. It should be between 19.5 to 21 from the air. So these are the 3 levels of the hold where we have to take the readings. Let's see this again first. Test the flammable gases which can cause fire and measure the toxic gases. The toxic gases possess health hazard, and then flammable gases can cause explosion. So you have top, middle and bottom. So sometimes the cargo is stuck here, but sometimes the cargo is stuck on the sides also. So we should check the gas on all the 3 levels, and every level we should wait for at least 2 minutes to get a steady reading, because from 20 meters the gas will come. It will take around 1-2 minutes and the reading will keep changing. So till the time reading is steady, don't keep waiting for getting the correct steady reading. Then you should keep yourself upwind. Upwind means air is coming from behind you, because if air is coming in front of you. So if this is the tank, stand here and wind is coming from here, because if gas is coming, it will come in the meter. If you're standing from behind, then the gas will not be collected in the meter or something. So keep yourself upwind when testing the gases and start the testing 1 meter before the potential gas area. So suppose you think the gas can be start from here, so start from here. Use the meter that is having the suction pump and use the tube to take the samples from the unreachable points. So you have a sample hose for unreachable. Then LEL and TWA for different gases, we know. TWA is for 8 hours duration in 5 times, 5 days in a week, and short-term exposure limit is 15 minutes, 4 times in a day. So this is long-term exposure limit, TWA, and short-term exposure limit is for 1 day, 15 minutes, 4 times in a day. So some gases cause toxicity or health problems in long term, some gases cause in short term. So it will be provided in the MSD. So oxygen is good in 19 to 23%. If oxygen is less than 19.5, then human beings and more than 23.5 also has health issues. Generally it's very difficult, but pure oxygen bottles have more than 23.5. And this is the range limit H2S. You should not be exposed to more than 15 ppm. And ammonia not more than 35 ppm. Carbon monoxide 30 to 50 ppm. And chloride 0.1 to 5 ppm. Then what are the flammable limits of a substance? We know LEL and UEL. So you should know for different substances it's different. It will be mentioned in your MSDS. So if it is below LEL, then this is the flammable zone. This is too lean and this is too rich. So here also fire will not take place. Here also fire will not take place. These are the LEL percentage for some gases. Methane is 5% LEL and 15% UEL. Then the ethane 3 and 15, butane 1 and 8, propane 2 and 9.5, and so on. Then you have exposure limits and flammable limits, which are mentioned in the MSDS as we discussed. Then next we have a gas meter, which is measuring your
gas detector,
hydrogen
which is from
gas.
Senko, and the model number being SI100.
Hydrogen sulfide is
So this SI model has several other gases.
multi-gas.
H2S.
This is a separate meter only for measuring hydrogen sulfide.
This one is
So rarely this is generally not found on the ship.
which is
Some ship you might find
used for any 2A, 2B, 2C areas and approved by several.
No one should enter or work in a confined space without a valid entry permit.
Same you have
Gives an
A
indication
valid
of
confined
where
space
it is running.
permit must clearly indicate the following:
calibration mode.
identification and
Also
location of the
calibration
confined space,
and,
purpose of entry,
further
date,
communication to
time, and validity duration,
SCADA, VMS,
potential
PLC,
hazards
or your
identified,
centralized
and the
monitoring
control.
system. This comes with a non-display.
अस्सलाम वालेकुम मैं हूं मुआज ख्वाजा फाउंडर ऑफ www.
We will see explosive meter.
Hello guys, so today we will learn regarding the working principle of explosimeter. As we all know that tank
So
scope
this
and
is the
explosimeter
working
are very
principle
important
of
gas
explosive
meters
meter. It's
which are
on
required
Wheatstone Bridge.
on board the ship. So let us see what is
And,
explosimeter.
It's
So
working on the
explosimeter,
principle
as
of
I have
Wheatstone
mentioned
Bridge,
here, that
and it requires at least 11% of oxygen.
at least
The
inside the
explosive meter
cargo
is
tanks.
used for
Only
measuring the
then we can
LEL
use
of your
explosimeter. Now let us start with
instrument.
working principle. It works on the principle
So
of
LEL
Wheatstone
means
bridge. So this is a
1% volume
Wheatstone
of
bridge which I have
hydrocarbon is
made,
divided from
and
0 to
one
100. That
arm
is,
is coated
so out
with
of
chemical.
100 parts
So you
of
can see
1% of
this is the
hydrocarbon, how much is the
resistance
gas?
resistor, and
Why 1%?
here
Because
this arm is coated with chemical.
hydrocarbon we have seen in
So which is a
flammability
sensing
diagram.
element,
We need
sensing
less than
filament.
1% of hydrocarbon
So
to
now
avoid
in this
flammable range.
filament, the
So in
chemical, it
Wheatstone
is
Bridge you
chemically
have 4
coated.
resistance, and
It is nothing but
center
we
you
can
have a
also
galvanometer,
call it as
and there is
catalytic
one
filament. So
sensing
when
filament
it is
or
coated,
this thing
and
which
now
is coated with
when the
this
hydrocarbon gas is passed
sensing
from the
filament.
gas meter, So the
and the gas
hydrocarbon
will pass
gas
on this
entering,
and it will change the
it
resistance
reacts
and the
with
reading will
the
show in the
catalyst.
galvanometer, and that's how we
Since
can measure
catalyst
the
means it is chemically coated,
LEL.
so it will react with this and it will change the temperature.
So
And
how it is
thus, if the
reacting? It is
temperature is
reacting as
changing,
a
the
like a
resistance will also
catalyst.
change.
It is
And if the resistance
this
is changing, it will
metal
show a
is reacting as a
deflection in the
catalyst
gas
for
meter, which will be
reaction
from
with
0 to
hydrocarbon,
100% LEL.
and it changes the
So
temperature of this metal.
explosimeter only
How
measures
more
from in
hydrocarbon,
the
more
in percentage
temperature, so
LEL,
more
that is
reading,
from 0
more
to
resistance, and more reading
100%
will be there.
LEL.
Same
It
way,
doesn't measure
so
in
as per the
percentage
temperature,
volume, and it
this
is
thing will
only
change,
used during
and with
gas
that
freeing operation to
we
check
can measure
whether
the
space
how
is
much
safe or
LEL of
not. So
hydrocarbon is
we have
there.
already in
So
a
this
process of gas
sensing
freeing, and
filament is
we just
coated with
want to see
some
whether the
chemical.
space, enclosed
It's
space,
called
is
catalytic
safe to
filament,
enter or not.
and
So we will be
when we
monitoring
will
the
use this
percentage
explosimeter,
LEL
it will be
of
used
the
for gas freeing.
cargo tank,
So we cannot
and thus
use in inert
we
atmosphere
use
because inert
explosimeter
atmosphere is
at
less than
that time.
5% oxygen,
So
and this
we are
is
clear,
11%
it
oxygen.
is a sensing
So
filament which is coated
explosimeter
with
is used to check
chemical,
whether the space is
and
safe for
the
entry or not.
temperature,
Before
it
man entry,
changes the
we need
temperature
21%
basically.
oxygen. That time we will do
mm,
gas freeing,
when the
and that time we
hydrocarbon
will use
passes,
explosimeter
it
to check
starts inside,
hydrocarbon
it
is
starts
below
burning, because of which the
1%
temperature
LEL
rises, and we all know
or
it
almost nil.
burns only because the oxygen is more than 11%. That is why the burning is taking place. Thus, this is the reason we
And the
require
filament will only
11%
work
oxygen
when you
at
have
least
oxygen
when using
more than
explosimeter.
11%.
Thank you guys.
Then we will see tank scope.
Hello guys, so now today we will learn regarding tank scope. As we all know that tank scope is a very important gas meter. So
So
let us
tank
see the
scope
working
is the most
principle
important gas
of
meter
tank
on
scope.
oil
And
tankers.
also please
Again, the
don't forget
working
what's
principle is
written here.
same.
It works in
It's
inert
on
atmosphere
Wheatstone
only,
bridge,
and
but it can
inert
work in
atmosphere,
inert
which means that
atmosphere.
oxygen which is
That
less than
oxygen
8%.
can be less than
So
8%.
let us see the working
How?
principle.
Because
It works on the principle of
sensing
Wheatstone's bridge. So
filament
Wheatstone's
is
bridge is made here, and here you can see all this resistance and the
sensing filament
galvanometer in between,
is
and here
working
one
on a
arm
different
is
type of,
with the
it's a
sensing
non-catalytic
filament,
sensing filament. So
but
filament is not reacting with hydrocarbon,
non-catalytic heated
but it
filament.
is heated
So
only.
this is a
So
sensing filament,
because
and
lot
it
of
is
gas is passing,
non-catalytic.
so
Non-catalytic
if it
means
is
it is
keep
not
reacting,
coated
so there
with
will be a
chemical.
problem. So
So
here only the
when the
filament is getting
hydrocarbon
heated.
gas enters the gas meter,
When the
it
gas is
reacts
entering with the
with this
filament,
filament. It is a sensing filament, so it will
the temperature
sense the
of change
hydrocarbon
actually, it
gas,
in,
and thus,
in explosimeter it
since
was
there
heated,
is no
now it will
chemical,
cool down
so
because of the
it will
resistance change,
react and it will cool down, thus
and the
changing the
temperature will
temperature, and
change,
thus if the
and
temperature
hence
is
the
changing,
resistance
the
will change.
resistance
If
will
the
also
resistance will
change,
change, it will show in the
and because of this
galvanometer
it will show a
what
deflection
percentage
in
of
the gas meter.
hydrocarbon
And
is
here you
present
can
in the
show
tank.
here you can see that the
So
um, level is like from 0
hydrocarbon
to
percentage volume
100%
from 0
volume.
to 100 in the
So
tank is
as
measured
we have
by
seen
पूरा
in
खोल के
an
दिखाओ.
scope.
explosimeter,
So when we will
the
use
reading
this
is from 0
hydrocarbon,
to 100%
अच्छा है.
LEL,
tank
so it
scope,
measures LEL, and this tank scope
so
measures
it is
percentage volume,
used to
and
determine the flammable
it
क्या
is
atmosphere.
ये
used to
ताश
determine the flammable
Uh,
atmosphere.
क्या लिखा? अच्छा लग रहा है.
okay. So it is used to
So
determine the
we can
flammable range in the
determine that
atmosphere. When we are
atmosphere,
doing inerting
this
or
is the
something,
flammable
how much
atmosphere,
is the inert
which will
gas
be
and how
showing
much
in
is the hydrocarbon in the
percentage
tank,
volume,
that time we
and
will use.
it can be worked
So
in
we can,
oxygen which is less than
if you are
8%,
asked which
because there
instrument
is
we
no
can use in
burning
inert
in this.
atmosphere, it's
So
tank
that is the
scope.
reason we
And we
use it
cannot
for
use
in
in
inert
inert
atmosphere.
that is
So this is
explosimeter.
all about tank scope.
Explosimeter
The
measures
simple thing
LEL
to
and
remember
tank scope
is
measure the tank
it works on
volume
the principle
of
of Wheatstone bridge,
hydrocarbon
and
percentage.
the sensing filament is a
And you have to
non-catalytic
remember it's a
heated filament,
non-catalytic filament
and it
in
cools
tank scope
down
because
when the
lot of gas will
hydrocarbon
be
gas
passing through.
passes the gas meter, and it changes temperature, and thus the after the resistance is
Then
changed, it will show the
next is
value.
which one will be
Hello
used,
guys, so
explosimeter
today
or
let
gas
us
meter,
discuss regarding
tank
the
scope.
explosimeter and tank scope,
So this question
what to
comes many
use
times.
and when to use this gas meters. So let us see the my
So
my
we have flammability diagram
this is my
which we
current
have seen.
tank
So when
atmosphere,
you
which is like
start
almost
inerting,
10%
you have
volume, and
lot of
oxygen is
hydrocarbon in the
also
tank,
somewhat
more than 10%,
7% by volume.
and we want to do
So
man entry,
what
so
should
we
I
have to
use
make
now?
the tank with 21%
Whether I should
oxygen.
use
So
tank
we
scope
start putting
or
inert
whether
gas
I
in the
should
tank
use
till
explosimeter.
you have
So
less than 1%
if you have
oxygen.
not watched my previous video regarding explosimeter or
So
tank scope working principle, so please
while we are
watch.
inerting, we will use
So
tank scope
let me show you
to
the
measure
tank
the
scope.
percentage volume of the
If you remember,
this thing,
we have learned
hydrocarbon,
that
percentage
tank
volume of
scope measures
hydrocarbon.
from 0 to
We will use
100% by volume.
tank
So it
scope.
measures in volume. So we can use tank scope because explosimeter
And
only
explosimeter works only in more than
measures in
11%
percentage
oxygen.
LEL.
And now
So
we
we
are
have to
inerting.
use
So
tank scope.
oxygen is
So
always
at this
less
point
than
F, we can use tank scope
5%
during
for nutrients.
purging.
So we will use
So
tank scope
once you
while
reach
inerting,
point
and we will
O,
keep introducing inert
now
gas.
it's
Hydrocarbon is
time
going
to
down.
start gas freeing.
Once
So
you reach
which
this
equipment I
dilution
will
level less
use?
than 1% LEL, then we will
Now
start
since the
introducing
hydrocarbon is less,
gas air,
oxygen is
dilution
less.
with air.
Now the
And
moment I
that
start gas
time
freeing, there is
hydrocarbon is less than
there is a
1%, and when the
requirement. There
oxygen
is
is more than
I am
11%,
required to
that time you can
measure the
start using
air which I am
explosimeter.
introducing. So
So
for
when
this I
the
can use O2 analyzer.
gas reaches
So
here,
from point O I will use O2 analyzer,
there is
but
more,
till what time I will
and
use?
till here
So you
to
can
here
see there is
we
a
will
point
use
E.
O2
It
analyzer,
is the oxygen level is
because we want to
11%.
check the oxygen
So
level.
this is the time we will use explosimeter,
Hydrocarbon we already know
because
is less than 1%, but
explosimeter,
oxygen we
as
don't
you
know.
all know,
So
that
with
it
oxygen
measures
we
in
will check
percentage
how much is oxygen. When
LEL,
oxygen is more than
and
11%, we will use
it requires,
explosimeter to
if I
check the
show you the
LEL percentage
explosimeter
of
page again,
hydrocarbon.
so here you can see that it measures in
Because we
percentage
saw in
LEL, and
explosimeter it's measuring LEL,
it
and
requires
it requires at
11%
least
oxygen, and it
11% of
requires this
oxygen,
because burning takes place inside
because
the gas meter, that
sensing
is
filament, the
the
burning
sensing
is taking
filament.
place, and
The
it's
burning
burning.
takes place. So
Hydrocarbon is
because
burning
of
with
this,
oxygen and making water and
for
carbon dioxide inside. So the
using
reaction
explosimeter,
increasing
I
the
should have
temperature and resistance of
11%
the
oxygen at
freeze-throwing
least,
bridge.
and this is the time I can use explosimeter because it also measures in percentage LEL. So I will keep on measuring from the explosimeter till
So
I
till the time
get
you
the
get
tank atmosphere
21%
to
oxygen and
1%
zero,
LEL.
almost zero LEL,
That is
we will
almost
keep
that is
measuring
gas
and
free
using
state.
the
So
explosimeter.
let us see what we learnt today, that we will
So
use
tank
tank
scope is
scope
used
when
when
we
we
are
are doing
purging,
purging,
or
or
whether the
the
tank
tank
is
is
in
in
inert
inert
atmosphere, then we
atmosphere
will
or
use the tank
inerting.
scope.
Then when
We
we
will use
start
O2 analyzer
gas
when we
freeing, we
are
use O2 analyzer,
doing the
and
start
when
of
we
gas
start
freeing operation, and we will use
gas
explosimeter
freeing, once you
when the
have
gas
oxygen
freeing
reaches
is
11%, then we will use explosimeter.
once the O2
So
reaches
this is very
11%
important to
during the gas freeing operation.
note down. Then last
Hello and welcome to
the
Instacart
gas
Holdings,
meter
your
is the Draeger
worldwide
tubes.
instrument partner.
So we
We
have
have
for
a pump
oxygen
from
and
Draeger,
other
and this
multi
is used
gases.
externally
The gases which
for
cannot be
doing the
measured with
testing
these
and to
instruments
check
will be
the
measured with the Draeger tube.
sampling
So
tubes.
this is a pump. So Draeger
Basically,
tube is for
this
various 117
Draeger
gases, but
pump
separate
basically is used
tube is there for
along with the
this
tubes,
type of tube.
and
Separate tube is there for different
the
chemicals
working
and gases.
principle is that we
So this
do
is a air pump
a calibration,
to
a
take
calibrated
the
100
suction of
100
the
ml
air or
sample of the
this
air
thing
is
from the
drawn
tank,
through the tube with the Draeger,
and there is a
this Acuro series
uh,
bellow pump,
meter
and if the
checking
targeted
how
chemical
many
is
times
present,
you are pressing
the
the pump.
reagent in the tube changes color, and the length
That
of
is
the color change
pumps
typically indicates the measured
counting.
concentration. Please understand that this
So this is a
particular
tube
tube
of
has to
glass
be purchased separately.
or a chemical
This
which
is
you have to purchase
not along with
separately
this
every
pump.
time for each
The
chemical.
standard accessory which
And then
comes with
these
the
are glass
pump
tubes which you have
is
to break from both
this
the sides
opener,
by this
glass opener,
breaker, and
glass
that
tube
tube we
opener,
will enter in the
this strap, and
this pump.
an Allen key.
And then you have this Allen key for adjusting any part of the pump or
I
something.
just make you familiar with this instrument. There are several parts of this instrument, just like the tube opener, with a ceramic cutter,
So
the
you
cover
have one
plate,
cutter here also
the
which you can
socket,
use, or you have this separate
the
cutter.
rubber bellows,
This is called bellow for
and
pumping
the lower
pump,
pump plate, this one,
and then lower and
the
upper
stroke
plates,
counter reset button,
then counter
the stroke
button,
counter,
then reset button for the counter,
which will give you the count of
and
how
this
many
is a
pumps you have
white
done,
light or gray light
and end to stroke
indication for
indicator,
how
then the
much is
bolt to
the
secure lower
pumping
pump
gas is coming in or
plate
not.
in place, that is that
So let's see how we are
this one,
using.
and the loop handle basically. So this consists of this pump actually, and for the glass tube, this is a chemical or a family of
So different
chemicals basically. The
tubes,
applications where we use
once
this all
we will see
is
the tube,
into ambient air for health
the tubes
and
are
safety
having
levels,
different
stack gases,
markings
motor
1 to
vehicles,
10, and it will be written how
pressurized
many
gas line
times we have to
samples,
pump. Suppose it is written
and
n is equals to
any
10,
other
so we
technical
will
gases or
pump the
analysis
trigger
of
tube 10
samples
times,
in the laboratories.
and then
For more information,
uh,
motor vehicles.
the gas from the tank will come in this tube, and it will change the color. So inside the tube you will have manufacturer instruction how much color or what color is changing up to what 1 to 10 which scale, and as per that you can count the ppm of that gas, how much gas is present, and also the expiry and the carriage temperature of this tube is mentioned in this tube box. So that's it about the gas meters. Anybody has any doubts? किसी को कोई डाउट है? ठीक है, तो मैं मीटिंग एंड कर रहा हूँ, तुम लोग मीटिंग एंड करके स्टार्ट कर रहा हूँ, फिर तुम लोग ज्वाइन कर लेना, ब्रेक भी ले लो, ठीक है?